Hello, everyone. Today I want to share with you the release of a new AI model, Tulu 3405B, that this is the first 405 billion parameter language model developed with a fully open training recipe. IT has demonstrated outstanding performance in multiple benchmark tests. This episode's content comes from the official blog of the Allen AI Institute. The Allen AI Institute is a nonprofit research organization founded by Microsoft co-founder Paul Allen, dedicated to advancing artificial intelligence research for the benefit of human society. The institute has deep technical expertise in areas such as natural language processing and computer vision, and has consistently upheld the principle of open science, actively promoting the open source development of AI technology. Let's first understand the key features of this model. From the evaluation data, the final version of Tulu 3405B after RLVR training performed excellently on multiple key metrics. In the comprehensive score that includes safety evaluation, it achieved 80.7 points, surpassing DeepSeek v3, 75.9 points, and nearing the level of GPT-4o, 81.6 points. In the Human Eval Plus Code Proficiency Test, it scored 93.9 points, higher than GPT-4o's 92.7 points. In the GSM 8K Mathematical Reasoning Task, it achieved 95.5 points, outperforming Llama 3.1, 95.4 points, and DeepSeek v3, 94.1 points. These data indicate that Tulu 3405B not only can compete with open-source models of similar scale, such as Llama 3.1405B instructed News Hermes 3405B, but can even reach or surpass the level of closed-source models in certain tasks. The training process of the model adopts a complete training recipe, encompassing 5 meticulously designed core steps. The first step is the data preparation phase. The research team meticulously planned and synthesized training data for core skills, including high-quality datasets in various fields such as programming, mathematical reasoning, and knowledge question answering. The second step is supervised fine-tuning (SFT). That at this stage, the model learns basic conversational and task handling abilities by studying high-quality prompts and responses written by humans. The third step is direct preference optimization (DPO). This is a novel model alignment method that directly utilizes human preference data to optimize model behavior. Simply put, it involves collecting a large amount of data on which of two answers humans prefer, and then training the model to produce responses that humans prefer. Compared to traditional reinforcement learning methods, DPO does not require training an additional reward model, making it more computationally efficient and the training process more stable. The fourth step is verifiable reward reinforcement learning, RLVR, reinforcement learning with verifiable rewards. This is an innovative training framework developed by the Allen AI Institute, which skillfully combines reinforcement learning with an automatic verification mechanism. Compared to traditional reinforcement learning methods, the unique aspect of RLVR lies in its verification mechanism. After the model generates an answer, the system immediately checks the correctness and safety of the answer through an automatic verification program, and provides clear rewards or penalties based on the verification results. This is like equipping the model with an automatic referee that can objectively and impartially judge the quality of the output and provide timely feedback and guidance. This method is particularly effective in training models to solve mathematical problems, programming tasks, and other scenarios that require strict correct answers, because the verification program can accurately determine whether the answer is completely correct. In the specific implementation of RLVR, each round of training iteration consists of 3 closely linked phases. The first is the reasoning phase, 550 seconds, where the model generates answers based on the current parameters, while the validation program checks the correctness of these answers in real time. The second is the weight transfer phase, 25 seconds, during which the system synchronizes and updates model parameters across multiple GPU nodes to ensure training consistency. The third is the training phase, 1,500 seconds, where the model parameters are optimized based on the validation results, reinforcing correct behavior and suppressing incorrect outputs. The final step is a comprehensive evaluation. The team uses standardized assessment kits for development testing, while also performing data decontamination processing to ensure that the model does not simply memorize the training data, and finally conducts the ultimate comprehensive performance evaluation. The uniqueness of this training method lies in its focus on both the foundational ability development of the model and its emphasis on safety and controllability. That DPO ensures that the model's outputs align with human preferences. Our LVR guarantees the model's accuracy in specific tasks. This multi-layered training strategy not only enables Tulu 3405B to perform exceptionally well, but also endows it with considerable safety and reliability. At the technical implementation level, training such a large-scale model poses numerous challenges. The team used 32 computing nodes, totaling 256 GPUs for training. Among them, 16 GPUs were used to run VLLM, a high-performance large language model inference engine, to generate training data. And the remaining 240 GPUs were dedicated to model training. To control computing costs while ensuring training effectiveness, the team used a smaller 8B scale reward model in RLRV training, rather than using a larger model to calculate reward values. This approach can significantly reduce the consumption of computing resources while still maintaining good training effectiveness. Interestingly, researchers found that large models and small models exhibit different characteristics when dealing with mathematical problems. For a large model like 405B, using the math dataset alone yields better results than mixing multiple datasets. This may indicate that large models are more suited for handling complex tasks that require specialized data. In engineering practice, the team also encountered some technical challenges in addition to the enormous computational demands, there are occasional NCCL, NVIDIA Collective Communications Library, timeouts and synchronization issues that NCCL is responsible for data communication between multiple GPUs. In large-scale distributed training, when hundreds of GPUs need to synchronize and update model parameters, network latency and bandwidth limitations may cause communication timeouts. This requires careful monitoring and intervention. Hyperparameter tuning is also limited due to high computational costs. The team followed the principle of larger models use lower learning rates to solve this problem. This is because models with more parameters are more prone to gradient explosion or instability during training. Reducing the learning rate can make training smoother, and although it may require more training steps, it significantly improves the success rate of training. There is some good news for developers and researchers who want to try this model. Tulu 3405B is now available on Hugging Face. Interested friends can try it out on the AI2 Playground. The model is currently hosted on Google Cloud and will also be available on the Vertex platform in the future. Overall, the release of Tulu 3405B demonstrates the feasibility and effectiveness of open training recipes on super large-scale models. Although it faced challenges in computational resources and technical implementation during training, the final performance proves the value of these efforts. This project also provides valuable experience for the development of even larger-scale open models in the future. Thanks for watching. See you next time.